and welcome to this ESS revision video on 2.4, which is about biomes, zonation and succession, and today we're focusing on the biomes module. So biomes are a critical thing you need to know about because they are likely to appear in every exam, because obviously habitats are one of the several biomes that you need to be aware of. So you need to be able to discuss what the different types of biomes are, and a biome is a collection of ecosystems which are sharing similar climatic conditions. And sorry, my pen wasn't working very well then. Opinions differ on the number of biomes there are, but effectively you need to know aquatic marine, aquatic freshwater, deserts, forests, grassland and tundra. And you should know for each biome what the specific characteristics are, and this could be what the limiting factors are, so what reduces the amount of tropical growth, or growth for example. So for example, deserts has a limited water, limited soil quality compared to a tropical rainforest. What the biodiversity is like, so again desert will be low biodiversity, in tundra there is low biodiversity, whereas in rainforest and marine areas there might be more. You need to know what the productivity is, so any of the tundras, any of the biomes near the equator have got higher levels of productivity. You need to know what insolation is, and if you don't know what the term insolation is and what that means, then you need to look here. So the amount of solar radiation received on a given surface. So obviously the biomes around the equator will have much more insolation than others. That can then directly affect the climate there. Precipitation levels are important. Obviously you want a certain amount of precipitation to allow for effective growth of plants, but not too much at the same time. And temperature obviously is a big factor. Now, continuing with temperature, we need to think about what are the impacts of climate. Well, climate controls what grows where, and that is obviously important. And the two main climatic factors on that list were precipitation and temperature. So obviously temperature is hotter around the equator, as that graph shows there. And also precipitation is going to be higher in certain areas. So precipitation is not always as obvious, because precipitation could be due to land mass, it could be due to altitude, which also can affect temperature as well. But temperature will obviously vary as you go away from the equator. It will become colder each way. Temperature changes because you've got less insolation from the sun, and therefore you have less of the sun's rays. And as well as latitude, altitude can also affect temperature. As you go up mountains, it gets colder due to the change in air pressure as you go up the mountain. A big factor that affects the biome is also the wind and ocean currents. So the wind is defined as horizontal moving air which moves from high to low pressure, and the wind actually causes the ocean current. So the wind goes across the top of the sea, that causes water to move away from the land, and it can cause upwellings to occur. And water is basically how heat is transferred globally. The energy that water either absorbs or releases as it changes state is called the latent heat, and it moves the temperature around the earth. And obviously you know that water, when it's heated up, ice is heated up, it melts, and that turns into gas, and if it's cooled down, steam will turn back into water, and that will turn back into ice. And this obviously has a big impact on where the different biomes are, because the different biomes are greatly affected by the state of water. So there is something called the precipitation to evaporation ratio. Now this is effectively one of the key things that you need to be thinking about, because it affects plant growth and productivity. So temperature, as you're aware, can cause evaporation, okay, and it can also cause freezing. So if the temperature is high, you get more evaporation. If the temperature is lower, you get more either condensation or freezing of water into ice. And rainfall is important, but how quickly water freezes or evaporates will affect how available it is for living organisms. So overall, what you want for a rich a rich and fertile soil is a precipitation to evaporation rate of 1, and that is what we have approximately when the rate of precipitation, i.e. rainfall and freezing, is the same as evaporation. And you can see here how that is affected around the world. So you have here globally approximately a 1-to-1 ratio. You can see here on areas of land that you might think have a higher level of productivity, that they are closer to 1. Okay, but then there are certain areas where there's low productivity. So for example, Africa, where we know there's a large amount of desert, there's a high level of water evaporation, but a very low level of precipitation, and therefore the productivity is lower because the PE is low as a result. So productivity is largely in biomes affected by the latitude. So what this means is areas that are generally in the equator area at a low latitude have a higher productivity, and you can see here the maps of the sort of forestry and productivity around, the green bits being the highest productivity. And that links to this bit here. You can see the highest productivity is the rainforest, and that has a high level of rainfall, but it also has a high annual temperature. If you maintain that rainfall, so you have quite high levels of rainfall, an average temperature, your productivity will drop down slightly. And then there's temperate forests, which also have a high productivity, which again have a good temperature, but a maybe less rainfall. And then at the bottom of this level, you've got here, shows subtropical deserts have very low rainfall, and their temperature is high as well. The temperature is getting higher as you go to the left, if you've not spotted that. Up here we've got the tundra, which will have very low productivity, and that is got a lower level of rainfall, but it has very low temperatures as well. So productivity is the highest around the equator because there is a higher temperature there. Now obviously that's a generalized point of view. You do have Sahara Desert here, okay, and areas where there are low productivity. It is due to both rainfall, as I said, precipitation, and the average temperature. So if you've got high temperatures but you have high levels of rainfall, that will allow the perfect conditions for photosynthesis, which means your food productivity, your food chains are producing a lot more. Plants are photoautotrophs, so they can make their own food. As the temperature drops and we come down to here, the enzymes in plants work slower, and therefore there is less photosynthesis. And as the water drops, then there is also less water which is needed as a reactant for photosynthesis. So the graph can be used to work out where the different tundras will be in terms of their productivity, due to the fact that they have difference in temperature and moisture levels. So you need to be able to talk about the different biomes. You need to be able to talk through what the different properties of the biomes are. So we're going to briefly do it now, but I won't be able to go into much detail because of the time. So if we start off with grasslands, grasslands are grassy biomes home to often many wild animals. It's mainly grass. It does have a good amount of rainfall each year, but often they're found in north of the equator, about 60 degrees latitude, because there isn't. They're often found in the centre of continents. The rainfall can vary. Often they have low productivity, but they'll be home to the particular animals and plants that live there. In some cases, because of climate change, you can have droughts happening there, but effectively you need to know that examples of it could include the North American prairies, and there are issues due to drought and causing ecological disaster there as a result. But mainly it's a dominated land with grasses. There isn't a huge amount of biodiversity there compared to other areas. Deserts then have a low biodiversity, and that is due to the fact that the precipitation and evaporation ratio there is a lot higher levels of evaporation than precipitation, so there's a lack of water. It is a limiting factor for the organisms that live there. Few species can actually survive the deserts. They have to be well adapted, and obviously the soil is not very fertile, and that is a problem. So there's very low levels of plants, there's very low levels of animals, because water is such a limiting factor, and food chains tend to be short as a result. Traditionally, we haven't done much damage to the deserts because we can't access them and use them. But particularly in Gulf states, we've been using the water underneath the deserts and oil in some places, which has made some areas of the world that are deserts become very rich indeed. And there's an issue with desertification, which is where areas of previously often grassland have slowly become more desertified, and that means less and less biodiversity as a result. They cover about 20 to 30% of the Earth's land surface, and from either side of the equator, but generally are in the middle of continents even. And therefore there are some deserts that are cold and some deserts which are warmer, but they often have no rainfall, so that is quite important. So basically they are dry areas that are usually hot during the day and cold during the night because the skies are clear, and they're off tropical, temperate and cold deserts, but there is a water supply issue. And then we come on to rainforests, which, as you should know, rainforests have a huge amount of biodiversity, huge numbers of plant species, which then accommodate huge numbers of animal species and other species. The productivity is really, really high. It's about 40% of the terrestrial net primary productivity of the planet. Plants grow fast. And as a result, because they have high water, high temperature, which allows the enzymes to work quickly, and then decomposition happens quickly, which means the soil is higher quality. The problem we obviously have is that we exploit the rainforest. A high number of humans live near the rainforest, and there's lots of resources that we want to extract and use. Tundra biomes are high in the Arctic Circle, and they're often been exposed from retreating glaciers. Tundras have very cold and have very low precipitation with long, dark winters. They make about 10% of the land surface of the Earth, but because of these long, cold, low precipitation winters, they have quite a low precipitation to evaporation rate. Very little gets evaporated, but the precipitation levels are high. Sorry, I said that slightly wrong. This means that very limited things can grow there. Often they'll be frozen ground, so there are no trees because they can't get to sustain enough light, but there's often a thick mat of low-lying plants like grasses, mosses and things like that are adapted to survive the harsh conditions. Often there'll be bare ground where plants can't grow. There's a low biodiversity, and the number I've got in front of me is there are 900 species in most tundras, as opposed to thousands and thousands, 40,000 or more in the Amazon rainforest. The soil quality is poor because there's low organic matter, because there's slow rate of decay. There are a few humans, but mining and oil has brought people in to do that. The ecosystem is extremely fragile because they have a low biodiversity, so therefore they have big impacts when we change them. The next one is the savanna. Now, the savanna is one where we have high levels of precipitation, often more than the sorry, reading it wrong off the top of my head. Sorry, the savanna is not the next one. I'm sorry, I'm doing temperate forests. Okay, and temperate forests have high levels of precipitation, much more than evaporation. There are fewer species in tropical rainforests because the temperature is a lot higher. Sorry, but higher in the rainforest, and therefore you get more decomposition there. So you get less decomposition rates, you get less temperature, so less growth of the trees. It takes longer for them to grow. There is a high productivity. It is second compared to the rainforest, but it is lower than the rainforest because there's less photosynthesis, less transpiration, and the soils also get frozen during the winter, reducing the amount of decay. Human activity has, obviously, we've used a lot of these forests, cleared a lot of them, so there are issues with this, but again, it's a high biodiversity landscape which we need to look at. So we need to be aware then of what is happening due to climate change across the world. And climate change is massively affecting the biomes and where the biomes are located, and there's something called biome shift starting to happen. So we can start to see the impacts of climate change across the world. We can see that there are more extreme temperatures happening, there's more drought happening, there's forest fires happening, floods happening. All these things are increasing because as the climate increases, we have got higher than average air temperatures than we used to have. So the air temperatures in the summer are about 2 Fahrenheit higher, 4 Fahrenheit in the winter. In the spring arrives about 2 weeks earlier in a lot of places, and winter starts 1 week later. The annual precipitation has changed across the world. So this is examples in Canada, but effectively there is more rainfall in certain places, there is less rainfall in other places. So you can see here the hottest days, the change in temperature is happening over the world over a longer period of time, and that is causing changes to evaporation, precipitation rates, and that can mean better or more or less, I should say, depending on where you are on the planet. Now, one of the things that climate change could affect is the atmospheric circulation, and this is really important because the biome distribution is explained by differences between air pressure and wind speed, which leads to different precipitations. So if you look at the start of the equator, rainfall at both the equator and up to 60 degrees north and south is high because the temperature causing more and more evaporation. Then if we go further away from the equator, rainfall is lower because again less temperature means less evaporation, okay, and then rainfall again drops as you go to the poles. So we need to be able to describe why the atmosphere affects where the biomes are. And obviously, as we said, it's a lot due to rainfall and due to evaporation. So if we focus on the idea of the wind and how that changes the temperature. So at the equator, there is a high level of rainfall because the Hadley cell is warm and unstable. So the Hadley cell represents this area here between 30 degrees north and the equator. And effectively the air is hot here because you get a high level of insolation, a high level of sunlight hitting the Earth's surface. The evaporation happens and the hot air rises into the higher levels of the atmosphere, and that means you get low pressure because there's low pressure, the hot air is rising, and that means once it rises it gets cool up in the sky and it forms sudden downpours of tropical rain floods. So then the next bit we need to know about 30 degrees up to sort of 60 degrees. So if you think about this area, whilst you may not realise it, a lot of it is actually quite dry areas. So like deserty areas, Mediterranean, things like that is very high, like high levels of dryness, and sort of southern America there you can know is a dry area. Now the reason for that is that the air is moving away from the Hadley cell. So as the air is moving away down from the Hadley cell that way and continuing to go down this way or continuing to go up there, the air is cooling, okay, and as it cools it starts to sink down, and therefore the air pressure is quite high. The air is dried out because the water's been lost already, and that's why you get desert biomes forming. Now when you get to the temperate forests though, the warmer winds continue to drive, but what happens is the warmer winds coming up here meets colder winds coming from the polar regions from the south down here. And what happens as a result is those two winds collide. The warmer air out of the two, which is obviously a lot lower temperature than the equator, rises. That warmer air takes moisture up with it, and therefore you tend to get more rain, but colder rain above 60 degrees latitude, which is in towards the polar regions. So this tricellular model then explains the reason why we have these conditions. So we have areas where there is a high amount of biodiversity because there is high amount of rainfall and high because of the Hadley cell causing that high levels of rainfall. And then you get other areas which have less rainfall and therefore you get less because the air is less hot, so it's sinking back down and it's not causing evaporation. And then in the northern hemisphere, again, above 60 degrees, you tend to get more rain again because the cooler air that is hotter than the Arctic air tends to go up, taking up cooler precipitation with it. So this is obviously having a big problem then, because climate is changing. So if climate is changing, air circulation is changing. If air circulation is changing, that's taking different amounts of water somewhere. Climate change is happening so fast that organisms cannot adapt quickly enough to survive it. So species movement is the only answer. So here you can see different species. So this plant, which is only found in the UK, is being slowly retreating northwards because it prefers cooler temperatures. And you see here that by the 2050s, it will only be found in Scotland. It's called what we call a fringe species because it's on the edge of where it can survive. And eventually it will go extinct because there's no more land that it can move up to keep with the temperatures. And we can see even this year, Scotland has been snow-free for the 4th time in a row, and that used to be rare, that there was always somewhere in Scotland where there was a bit of snow in the mountains. So species are tending to move towards the poles or higher up mountains to keep cool. So species often are moving towards the equator if they're looking for water supplies because of the heavy rain there. And obviously, as I said, animals have a tendency to migrate, but plants and other find it much more difficult, and other geographical barriers may prevent movement and lead to extinction. This is then causing a shift in the biomes. So biomes obviously is for these collection of similar climatic activities, and if you think about biomes, things will change. So we've talked about the fact that desertification is happening more. We've talked about the fact that the Arctic the Arctic conditions are getting worse, and they're getting melting, they're disappearing. So the biomes are shifting. African forests are becoming more likely to become savannas. Arctic tundra is becoming shrubland. The deserts are increasing in size. We know rainforests are decreasing in size. So biomes are shifting, which will have a massive impact. And therefore, as a result, the areas where the species loss is greatest is going to be these hotspots. And as we know, a lot of the hotspots are in like the rainforests and things like this. And this is causing massive habitat biodiversity loss because the areas might be specific, isolated, and the species can't migrate out. So the Himalayas are often one area that's overlooked. They're often described as the 3rd pole, so not the North or South Pole, but the Himalayas, because it's so cold there. As the temperature increases there, animals that have survived there have got no way of therefore surviving, as there is nowhere for them to move. The Mediterranean has very specific conditions due to this very narrow entry of sea from the Atlantic, and therefore as the temperature changes, as salt levels change, this could cause massive problems. And Madagascar is another particular area because it's cut off by a large area of sea from Africa. Very unique endemic species have very specific habitats, and therefore the animals can't survive the change. Now, humans are obviously living in these biomes as well, so it can also provide us with vulnerabilities. So, for example, we may not be able to gain the resources we want if the rainforest has gone, however, and it could affect our climate. However, there are also opportunities. So the ice caps melting is freeing up this route here, which is allowing ships to go around North America from the sort of Asian continent to Europe, instead of having to go through the longer journey from the south here. So that is, so this journey would take a lot longer. So there are opportunities which could potentially be there, and ice is obviously melting, which is allowing certain companies to go to places they couldn't do to maybe extract oil in the future. And there are an example that you're expected to know, which is the Sahel region of Africa. And here you can see a particular climate biome shift, because what is happening is there was an area which was savanna, which is becoming more and more desert as a result. So again, increasing deserts, and savanna biomes are appearing more instead of forest. So it's happening because of the change in temperature and the lack of precipitation, meaning the forests are no longer able to survive.